Many of you have noticed that when you present your research problems during our weekly community sessions, I always comment. One comment that is consistently common among all your presentations is that your research problem is not really a computer science problem. This arises from the confusion uh, between an application domain problem and a research computer science or computing research problem. I don't want to emphasize here computer science. Of course, I always, uh, sleep and say computer science, but I really should be using the term computing because computing includes all the areas of computing. That is computer science, information systems, software engineering, IT, and even computer engineering. So uh, many of you are in either or in a computing domain, one of the computing domains. But when you present your problem, you present it from an application domain perspective. Therefore, there is a lot of confusion within this community uh, between application domain problem and computing domain problem. As a supervisor, for instance, if I'm to supervise a PhD, I'm not going to supervise a PhD in healthcare, in agriculture, in supply chain, in business, and all that. Those are PhDs that are done somewhere else, right? But for those in computing, in information systems, in computer science, in IT, software engineering, and all these other domains, you must present a research problem in that area. If you don't do that, then it's not like you are not you are confusing. You are not thinking like a researcher yet. So in this presentation, I would like to discuss, to try to sensitize you to the differences, or to enable you to be able to distinguish between an application domain problem and a computing research domain problem, research problem. The reason why it doesn't mean, what I'm saying here is that I don't want you to come up with the idea that the application domain is not important. It is important mainly because the government, all institutions are saying your research must be relevant to the country. You should not mistake that as saying that you should do your research in another area. No, you still do your research in computing, but keep your application domain. But if someone asks, what are you researching about? We don't want to hear about the application domain. We want to hear about your area, research in your area. That is important. So I will use this whiteboard to write. We have an application domain, right? I will write in brief here, in abbreviation so that it works. Then we have the computing domain, right? Uh, so the application domain is very important, or rather, the way I've written here might confuse you guys because I am starting with the application domain. I would rather start with the computing domain, right? The computing domain. And from now onwards, you guys, you should use the term computing to mean um, all the areas of computing. And of course, there are many application domains. There is healthcare, there is agriculture, there is business, and there are many other application domains for computing, especially. It's more like in mathematics. Every domain they do some bit of mathematics. So that is very important to know, um, that uh, we do, our computers are being applied in these other areas. Right. So the application domain is important because we do need to pay attention to it. But this is not where our research problem comes from. So we always have a, when you are doing research, start by identifying a problem in your computing domain. You must have a problem in your computing domain, right? So I will call this P1. And your goal, of course, is to come up with a solution, a solution. Your solution is a contribution. So I will call it S1. And that's your goal, to come up with uh, this particular as a contribution. Your solution, of course, we will discuss as we go on what sort of solutions is relevant, especially of doctoral at doctoral level. So you need a research problem. Your research problem can come from the literature, right? It could come from the literature. I will use L here to indicate the literature. So it could come from the literature, uh, preferably, because that's the fastest way of identifying your problem. Of course, there are other sources. I've already talked about this. You can talk to a senior researcher who already works, is a researcher, an active researcher. They normally have problems on the shelf. They know, they have read the area and so on. But it's not a good way to come up with a research problem, because your your supervisor has done the thinking. He is failing to train you in identifying a research problem. How do you come up with a research problem? When you finish your PhD, you must know how to do this so that you can train your students as well. Because the assumption is that when you do a PhD, you're going to train others as well. Right. So you must learn how to use the literature to come up with a research problem. If a supervisor gives you, you have skipped a very important step for a researcher. You have to think like a researcher, look at the literature, and identify a research problem. Right. That's something that we will do on another day. But for now, this is one source of a research problem. Right. But sometimes we are motivated by a problem in an application domain, which explains why you guys always start with that and say, "Oh, this is my research problem." But in fact, it's not your area. Your area is a computing domain. This is important. It must be in a computing domain. And when you state it, you should not even mention the application domain. We should just hear the computing domain problem. Right. It's only later, maybe when you want to, when someone asks you, how do we know that your solution works? That's when your computing problem you apply it to a computing problem. So uh, this the, now uh, now let's go on to look at the other source. Most of you, because you always start with a problem in this area, it's not, I'll call it P2, right? Yes, most of you are motivated by the application domain, because this is what we want. We will go to agriculture, we go to commerce, and we try to find problems that are relevant to our country or to our environment, and therefore we end up being able to say, okay, from a problem, you now need to move to your computing problem. It is important always, when you are motivated by an application domain problem, now proceed to ask the question, what is the computing research problem? And find it. If you want it to be linked to the application domain problem, you still have to find it, right? Because that definitely is a source of your computing research problem. But sometimes you might want to do it properly. If you were to do it, the very best way to do it is to look at the literature, look at the current state of knowledge in a particular, in the literature or of an area that you like, and then identify a research problem. But when you do that, you remember to say, okay, how do I check whether my solution works? That's when you look for a problem in your country. Then you apply it as a last item, as a methodology to check that your contribution works. So, in that case, the domain problem comes from the research problem. In that case, you move from the computing research problem to a particular problem in the application domain. Usually, this is a more important way to do it. You move from your literature, identify a gap, and then that gap usually is linked to some problem in your country. So to make it relevant, you then pick that, but you select that area and you apply. You say, okay, I will check if if I manage to achieve this problem, then I must be able to solve a problem in my country, and you can then look for it and use that as a case study only. So, but when someone asks you, what are you researching about? You don't tell them the application domain problem. You tell them the computing domain problem, right? So there is a role to play for the application domain problem, but don't make it your research problem. Many of you do that. I've seen almost all the presentations that have been done in our community research have got this mistake, right? Now, usually, you do most of your research, all the period of your doctoral research is based on the computing problem. And only when you come up with a, a solution in the computing problem, that's when you now start visiting the the, the research problem. Now that you are equipped with a solution in the computing problem, you then now address that problem and apply the solution to the computing problem to your application domain problem, and then come up with a solution in that area. You then come up with what I would label as solution two. Solution two being the research problem that you then arrive at after you have applied your computing problem, right? So this diagram is important to you guys. And when you have found the solution to the application problem, you should now say, oh, my solution to the computing problem works. So you now go back to your solution and say, yes, it works. Yes, it works. Hmm. And then it validates your research. It's, in other words, it's evaluation. When you come to evaluation and validation phase of your computing research project, that's when the application domain problem comes. And it's a methodological issue. It's not a research problem. It's a method of checking that your solution works, right? So now, if you look at this diagram, the application domain problem plays two roles. The first role is that it can inspire your application domain problem, P1. P2 can inspire. In other words, you go out and see a problem in a particular area, and then you find, okay, these guys are facing this problem. There may be a computer. We can probably get help from technology. And then you say, okay, but what what research problem can arise from this problem, and you look for it. There are many ways you can look for this. You can do another literature review related to the portion that you believe is important to your application domain problem, and redefine whether there is a gap in the literature relating, and then you discover. There are many ways of discovering P1 from P2. Once you discover it, now that's your research problem, right? You work and find a solution, S1. Once you find S1, you go back to the inspiration. where the problem that inspired you, and you address that problem to come up with a solution in the application domain. When you come to the now it's an evaluation. When you evaluate S1, evaluating S1, simply go back to the problem in the application domain and solve it, and come back and say, whoa, my problem works, or works to this extent. It doesn't work to that extent. It only limited. And you could say part of future work, or if there's anyone who want to do more research, you may want to improve on this solution so that the application domain problem, we can get a more robust solution or something like that. So you can keep it as future work. So that's this is very important, right? In summary, I have seen that our community lack the ability to distinguish between application domain problem and computing domain problem. So I'm here saying it is important for you, once you pick an application domain problem, you must find the computing domain problem. Don't make P2 your research problem. It's P1 that you should discover. You may be inspired by P2, but you discover P1 and then find S1. Only when you have S1 can you go back to the application domain problem as a way of evaluating. When you say, okay, how do I know that S1 is a valid contribution? You at least apply it to the application domain and find S2 and say, oh, this is and then assess it S2, which then help you to assess whether S1 works effectively. It's only at evaluation when P2 is when S2 is important. And P2 has got two roles. The first role is to inspire you to find P1. And the second role is to evaluate the solution so that you come up with S2, and then S2, the quality of S2 will then inform us on how your contribution works or is important. So I encourage you to think carefully, look carefully at this diagram. When you want to formulate your research problem, it is important to know about P1, P2, P1 and S2, and distinguish these two from P2 and S2, and know the role of these two, right? S1, the role of S2 is to evaluate S1. So you apply S1 to P2 to come up with S2, and then evaluate to what extent have you come up with can S1 be functional in the real world, right? That, in summary, is my objective for this. So after listening to this video, you should now be able to formulate your problem. You can state P1 as your research problem, but you can also indicate that you are evaluating it using P2 and S2 to show that your S1 works or it's a valid solution, right? Goodbye. I end here.